We're going live. Hi everyone, and welcome to the 7th round of the NewDeal Invest live Q&A here on YouTube. Thanks so much for tuning in. For the next hour or so, we will be answering your questions live, just as we always do, discussing anything in relation to the stocks that we follow, our portfolios in NewDeal Invest, or anything else that you think we might find relevant. Please ask your questions in the YouTube live chat as we go along, and we will try to get through as many questions as we possibly can. My name is Jesper Beck. I am a UX designer and part of the portfolio team here at NewDeal Invest. With me, as always, is Mads Christiansen, founder and Chief Investment Officer. But today we also have a very special guest joining us, Simon He. But Mads, I was thinking perhaps you could just introduce yourself first before letting the word go over to Simon.
Yeah, thanks, Jesper. I founded NewDeal Invest, a tech investment company creating broad tech portfolios with companies from the AI space, cybersecurity, microchip sectors. So our investors get a broad exposure to the tech stocks, and with a weight that is different than the many big portfolios and ETFs out there, which is very much skewed to the big companies. So you get a good diversification in the smaller tech space here. And it's a great pleasure to have Simon He with us. Simon is also a part of the NewDeal Invest portfolio team. Please tell us something about yourself, Simon.
Yeah, great. Yeah, thanks for having me here, and really looking forward to the conversation. So my name is Simon. I am a co-founder and equity researcher from competitve, which is an equity research boutique specialized in cybersecurity, data analytics, SaaS, and semiconductor. And unlike many other sell-side analysts who focus more on the channel checks, we differentiate ourselves with deeper look at product architecture and the vision of technology companies. And we believe that because our deeper dive into the specifics of these companies, we can gain a better visibility into the long-term thesis that can provide more information edge for investors.
Yeah, so you look at more at the technology and have a lot of your research weighted there to try to predict long-term outcomes of the companies, tech companies competing with each other.
Yeah, definitely. So, a lot of financial-oriented analysts, they are 100% focusing on financial. Well, there are some industry analysts who are more focusing on the technology, but there is a good combination of both worlds. And we look for, combining both technology understanding, but also the finance and business strategy, such that we can uncover what's truly unique in terms of the investment thesis.
Awesome.
That's great. Yeah.
Just before we get started, guys, I just want to note that none of what we discussed today should be considered investment advice. We're simply here to nerd out on stocks and have a great time today. So everyone watching, please always invest at your own risk. But I was thinking just as something different today, it was actually Mass's idea. Perhaps we could get started with just discussing what kind of companies we think, or perhaps pick one company today that we think is the winner of the week. Mads, why don't you give it a go?
Okay, yeah. My company is definitely Apple. I think they crush it at the developer conference, and I think that they proved that they can be the aggregator of AI. So that you use the Apple ecosystem whenever you want to use AI, and the secret weapon there will be the iOS, the operating system of the smartphone. It knows everything about me, so it is the place where there's most context about me. So it's a perfect place to start and AI journey for me as a consumer. And thus, I actually, if I should name a loser, it could be Microsoft, because they don't have an iPhone or a phone operating system to be center of the consumer AI journey. Yeah. So that's mine. What's yours, Jesper?
Before I was just gonna ask, like, do you think that because they have this deep OS level integration, do they necessarily need to be the best at AI, or is that just simply enough a great enough advantage that they can beat out Microsoft?
No, that's actually why I say aggregator, because they don't need to do the AI themselves. They have the data, they have the context, so they can do a lot of really good stuff with own AI, and like they did the agreement with OpenAI. So now that if Apple Intelligence is not enough, they'll just make a segue for you to use the OpenAI services, and kind of the news that they are getting the OpenAI services, ChatGPT services for free is sort of implying that large language models could be commoditized in some way by somebody like Apple.
Great point. Yeah. If I'd had to pick one, I'd say Tesla is actually the big winner of this week, because we had the annual shareholders meeting, and what the company and what Elon has been fighting for so long, for the past months, is getting his pay package reapproved, and also having their operations moved from Delaware to Texas, and all that went through, and it was a big celebration. Elon was clearly very pleased with the result, and we got some great, exciting, I think, prospects for the future, and I think just a whole lot of uncertainty lifted off the stock, because what would have happened if he didn't get his pay package? You know, there could have been chaos. It could have been lots of weird negative things. So as a Tesla shareholder, I'm really pleased with what has been going on this week.
Yeah, it's a win for Tesla, right?
Yeah.
That Elon got his package. Yeah.
Definitely. Yep. Simon, do you have an example for a winner this week?
Yeah, definitely. I think it's Broadcom. So, they crushed it in terms of the earnings and the guidance. And also, they are following NVIDIA in terms of having a stock split. So this is also a great thing. But the biggest underpinning is just their AI chip. They are making the AI chip for Google TPU, and then Google is just spending massively in terms of order to catching up with other, especially for Microsoft, in terms of the AI leadership. And then also, Broadcom, they are just signing more AI chip deals with Meta, and now potentially is ByteDance, who is the third customer for their custom AI chip. And then I think the biggest long-term features for Broadcom is just that people are just building even bigger AI training clusters. So right now we have about 20K GPUs in one cluster, but in the next 5 years, we have to have 1 million, and then that requires the network interconnect, and that is a great tailwind.
And do you think was there some clarity about the networking competition between NVIDIA and Broadcom?
Yeah, it seems like they are quite close. What's interesting, the NVIDIA locking, so they wanted to figure out whatever they can to reduce the exposure to having the need to buy the entire NVIDIA stack. And having Broadcom is a very strategic one, so it's very much preferred by just basically every hyperscaler. They don't want to buy 100% on NVIDIA, so they want to spend at least a bit of money on Broadcom in terms of the open architecture.
Right. It was certainly a very
yes, but there were some questions.
Yeah, we have some questions that came in before the show from Jens Peter. It's a question surrounding the competitiveness of SaaS companies in comparison to the major cloud providers such as Amazon, Microsoft, and Google. The question is, do the SaaS companies offer a good enough value proposition for customers to prefer them? Yeah, that's the question. What do you guys think?
So I'm kind of unclear about the question. Like, what does SaaS mean? It seems like what they're alluding to is the infrastructure SaaS companies like Confluent, right? Who may be kind of more competing with AWS. But if you're speaking the pure SaaS company, like
Yeah.
productivity SaaS company, then they're not.
You don't think
Yeah.
they're?
So yeah.
But we
So
see,
I mean, yeah.
Jesper,
So
Jens Peter also asks about MongoDB competing with big tech. So I think we see big tech coming, entering some of the things, some of the markets where we thought that some of the SaaS companies had sort of carved out their own niche or something like that. Where do you think they can compete in the future, and MongoDB maybe specific against the big tech players that are offering the same kind of databases? I think they're competing with BigQuery and
so for MongoDB, the competitor is DocumentDB from AWS, and then CosmoDB from Microsoft. I think for MongoDB, I think it's fine because MongoDB, the interesting thing is that they are the open source leader. So by definition, you're only going to have one or two leading open source projects because you have that gravity. Everybody is going to centralize and standardize on one open source project only. And then the most prevalent open source project right now in terms of the non-SQL database is MongoDB. So I think so widely adopted. So even for Microsoft and AWS, when they are building their own non-SQL DB, they have to provide API compatibility for the MongoDB. So this is a great thing. So MongoDB, it can change API whatever it wants, and everybody has to follow. So I think for MongoDB, it's kind of fine. But for kind of second tier players like Elasticsearch, it is a total different story. So yeah, I think it kind of depends.
Okay. But so for the pure SaaS companies, as you described it, you don't think they're competitive enough with the major cloud providers?
Oh yeah, definitely. If it is the end software application provider, like Zoom or Monday.com,
Yeah.
those guys, or Notion, they're just not going to compete with AWS. But what AWS and Microsoft they're going to compete with are the guys like infrastructure software companies like Confluent, MongoDB, because these guys they provide the infrastructure software that compete with guys like AWS and Azure.
Okay. Is there anything you would look for this situation to sort of change? Is there anything investors should be looking for this sort of story to turn?
Yeah, so I think in general, independent guys like Confluent and MongoDB, especially these are the independent and well executed guys. It seems like their competitiveness against hyperscalers uh, is great. Uh, it's not a big concern for them. But potentially in the future, I think just one caveat is that people are just always constantly looking for reducing the price. And for hyperscalers, because they own the infrastructure, while for Confluent and MongoDB, the infrastructure runs on top of Azure AWS. So for Azure and AWS, they can compete on the pricing very aggressively. But right now, because we're in the initial stage of the on-ramp, people don't care that much about the pricing as compared to the feature, the functionality. But if we are going to have a stagnant innovation, then people will consider, okay, we kind of have the same product or kind of having a commoditized product. And the hyperscalers, they can provide a cheaper price for these commoditized products. Then I think that is going to be game over for guys like Confluent or MongoDB.
I think CrowdStrike is competing somewhat with Microsoft and GitLab is competing with Microsoft's GitHub as well. And I think a lot of people are sort of trying to figure out whether that's sustainable or what their differentiation is.
Oh yeah, definitely. I think it's also a kind of similar framework, like commoditization versus a specialization. So right now, Crowdstrike and GitLab, they have very differentiated products. They have better innovation. They have better kind of stuff because they are the standalone company, so they can have a greater focus. While for Microsoft, they don't care that much about it. They can just simply sell these solutions as a part of the bundle, and they can sell it at 1/10 the price. So right now, both worlds they are progressing on their own ways. So for small and medium businesses, they want to have cost-effective solutions, so they will go with Microsoft. But if you don't care that much about the price, but the performance or the feature, then you will go with CrowdStrike or GitLab. So, but are we going to see those two worlds converging in the future? That's something we don't know. So it kind of depends. If the solution is getting commoditized and there isn't too much innovation, and then Microsoft they can catch up to commoditize these latest features introduced by the likes of CrowdStrike or GitLab, then this is going to be a tough time for them. But if GitLab and CrowdStrike they can continue the pace of innovation, kind of still keeping ahead of Microsoft, then this is not a big concern.
I think we've seen it also in my space with e-commerce and consumer what do you call it, internet companies, where every time Amazon entered something, people has been like, oh my God, Amazon just entered it, and the consumer tech company just plummeted. But it's very rare that they are actually able to outcompete an agile best of breed a product or company that has a dedicated founder that is really really innovating fast and being consumer oriented.
Definitely.
Yeah, and they sort of have to compete in some sort of niche, right? Because there's no way you're taking up the general fight with the big three. Yeah, they can simply do too much. Jens Peter also asked specifically for Snowflake what their competitive edge is in comparison to someone like Databricks. Is there something they offer that no one else offers?
Right. Well, yeah, that is a very big question. So, well, for Snowflake versus Databricks, so two kinds of competition. So one is data warehouse, kind of for the data analyst, business analyst, the solution, data warehouse, and the data lake, which is more catering for data scientists. So those are two solutions. And Snowflake, they had the root from the data warehouse. Well, Databricks, it has the root from the data lake. So both worlds are converging too. So for Snowflake, their competitive edge is from their data warehouse, and then Databricks is for the data scientist. But I think the good thing about Snowflake versus Databricks is that it's just the overarching philosophy that is different. Databricks is more like a very technical, hardcore engineer that company. They want to serve just only very technical engineers. While for Snowflake, they wanted to make it simple. They wanted to make the technology really simple to use, simple to deploy, easy to learn, kind of. So I think they are really kind of trying to be the Apple or the iPhone of the data analytics, while Databricks is more like Android. So there is a higher learning curve, and also iPhone is just focusing on simplicity, ease of use. I think both approaches are good. But I tend to prefer Snowflake because that is going to be 10x or even 100x the person now, the potential user of the data analytics versus Databricks. Because for Databricks, you're only serving a very small niche elite engineers who can understand the complex world of data analytics. While Snowflake is trying to make it simple, so I think that is a good thing for Snowflake.
Simon, Databricks acquired Tabula, a company here, and there was a lot of talk about it that they snatched it away from Confluent and Snowflake, and I think a lot of people are calling out that this was the end of Snowflake, or at least that it could be a problem for Snowflake. What's your take on it?
Yeah, I actually see the other way around because if you think about what Tabular does, it's basically open core company is the commercial entity behind open source project called Apache Iceberg, which is an open table format for the kind of lakehouse architecture. But what's interesting is that back like 4 years ago in 2020, there are 3 leading candidates for becoming the lakehouse standard. It's Delta Lake, which is open source by Databricks, and another project called Apache Hudi and Apache Iceberg. And what happened is that Databricks, they wanted to say, use our standard, use our Delta Lake. But everybody else is saying that we want to standardize around Iceberg because Iceberg is the truly independent open source storage format. While for Delta Lake, it's controlled by Databricks. So and then fast forward to 2024, it's clear that everybody is adopting Iceberg. And then for Databricks, they said that, okay, it doesn't matter. We can provide a abstraction layer that helps you to connect Delta Lake, Hudi, and Iceberg all together. You don't need to care which format you need to use. But they failed to engineer that project. And now they are seeing that, okay, everybody is adopting Iceberg. And Delta Lake is kind of getting smoothed out. And then, they have a big threat. If they don't gain more foothold into Iceberg, they will lose this standard game. And it's going to render their position obsolete because Databricks has been a company that is focusing open source from the beginning. And if they are not winning the open source, then that is going to be a big threat. And then now, what they have bought Tabular, which is the open source company behind Iceberg. So is it a bad thing for Snowflake? Actually, no, because what Iceberg is, it is pretty much an independent project. It's an open standard, but to make it really work, you need something called catalog, which is the governance layer that controls the assets, like who owns which table, who has the access to this specific data. That control layer, that catalog, that metadata catalog, is not within Iceberg. And recently, Snowflake has open sourced the catalog called standard for the catalog. While for Databricks, they have their own catalog called Unity catalog, but their Unity catalog is proprietary. So presumably they have to buy Tabular, and also presumably they need to open source Unity catalog, because otherwise everybody is going to standardize not only around Iceberg, kind of for the underlying storage, but they're also going to use Polaris catalog as kind of the upper control layer of the Iceberg from Snowflake. So that's why I think there's a bigger pressure from Databricks to acquire Tabular.
Interesting. I love the analogy of Snowflake being the iPhone, which is easy to use. I think another difference that I also have a little bit hard to figure out what structured and unstructured data. As I understand it, Snowflake is structured data, whereas Databricks is unstructured data, and I think there's been some talk about that unstructured data is the value of that is increasing due to AI and the accelerated compute. Could you talk something about that difference?
Yeah. So basically, I think a way to understand structured versus unstructured is that for structured data, you have a clear understanding of what it is, and it is clearly defined in a table format. You have rows and columns. While for unstructured data, it's mostly documents. For example, you have one image of, say, a textbook, and then if it is saved in an image, then it is unstructured. But if you extract the text out of the image and then save it in a table, then it is structured. And then for Snowflake, what they are saying is that previously, if the data is not structured, then there is no good use out of it. But yes, with the power of AI, then there is a good use of it. But for Snowflake, the interesting thing is that from the beginning, they are not just for the structured data, they are also for the semi-structured data. Then they are not for the unstructured data. So the difference between semi-structured data and unstructured data is that semi-structured data, you have the metadata about the unstructured data. So even if you have an image, you also need to know the attributes of the image, like when was this image created, what's the size of the image, things like that. So that's what they call semi-structured data. And then actually, I think the Gen AI is good for Snowflake in the sense that apart from you need a lot of unstructured data for training, but apart from that, you also need to make sure that the unstructured data is governed. It really treats the privacy security very well. And you need to figure out if this unstructured document contains any privacy related data. And then you need semi-structured data to govern it. And then that's where Snowflake has a niche. So I actually think that it's actually not a bad thing for Snowflake. But yes, Databricks, they have that niche because they originated from a data lake. So they have huge amount of data dumped. But the issue for them is that they don't have the semi-structured data, or they don't have the metadata for these unstructured data clearly laid out. So yes, you can use a lot of data to train your AI from Databricks, but you need to be careful about the data from Databricks because most of them are not clearly labeled. And then you can run into a risk of privacy concern like GDPR in the future. So I think it's all pros and cons both for Snowflake and Databricks.
All right, cool. We actually have JB Tralf asking, what about companies like, well, he mentioned Snowflakes, which I think we have talked about, and then Confluent as infrastructure companies.
I think
Right,
you were
so
around it a little bit, Simon, with them, but I think Confluent, that would be really interesting to hear your take on versus the big guys.
Yeah.
right, yeah. So I mean, for Confluent, I think it is a pretty good thing. I think the paradoxical thing about Confluent is that we call their business model open core. So basically, it means that you are open sourcing your software. So the source code of your software is freely available, and everybody is able to use it. And so, for example, AWS and Microsoft, they can use the source code from Confluent, Apache Kafka, and then they can build out their own solution. So everybody thinks that, okay, this is. But what it turns out is that.
Whoops.
I
Yeah.
think your sound went.
All right.
No.
Technical
Should I say
issues.
something? So this is live.
Yeah, that happens. I guess it's probably just the batteries on his headphones.
Can you hear me, guys?
No, it doesn't sound good. It sounds like you're a goldfish.
Yeah, a little bit.
Right. Let me try another way.
You're very far away.
What about this one? Can you hear me?
Yeah, but it's not good.
Right. Let me try.
So I'll just tell a little bit about Confluent while someone gets
Yeah.
his gear okay. So Confluent is a company that is built around this open source software that is made from a couple of guys from LinkedIn, and it's constructed to have data floating around. So it's transporting data and making sure where data is. So when the consumer is using his web bank on the phone, then that data also has to be somewhere. So data is in the network, and that's what this application is good at. And then the business proportion for Confluent is that it's actually cheaper when you use Confluent to assess the software, and they do cloud management, and they do all the stuff that makes it easier. Whereas for a legacy company or a company using their services, if they didn't use Confluent, they'd have to hire some technical staff, and that would have to operate the stuff, and the cost of having track of data all around would be higher than if you pay Confluent to do it. Is your sound okay? Yeah, that's good.
Yeah,
Well done,
Is
Simon.
my sound okay now?
Yeah, works
perfect.
fine.
Yeah, that's great. Yeah, so maybe I will continue. So apologize for that. So for Confluent, the interesting thing is that they are open core. But what's interesting in recent years is that there's a differentiation that they can try to provide in the sense that, yes, their source code is provided free. Everybody is able to access it to build out their kind of competing solution versus Confluent. But Confluent, what they're doing is that they are providing their own managed service. And then they just figured out, okay, Kafka. So for example, for Apache Kafka, it was designed not from the cloud world. So there are tons of technical depths associated with Kafka. And then they are building their own managed Kafka, and they completely re-architected Kafka, transformed it to the cloud native architecture. But what's special about it is that all of these re-architecture is proprietary, so they don't share it to the public. So now they have a cloud native version of Kafka, but that is only available from Confluent. And by being cloud native, they can provide, say, 10x more performance with 10x cheaper price, such that even if Microsoft and AWS, they can compete on the price, they cannot really lower down the price by 10x if they don't re-architect Kafka from the ground up. So that's what we call open core 2.0, in the sense that, yes, your software is open sourced, but the managed service from you, only 20% of the components is open source, is pretty available, but 80%, but the rest of the 80% is completely proprietary. And this 80% makes your software 10x cheaper, faster versus the open source version. And you can only get it, your customers can only get it by paying Confluent as opposed to going to AWS or Azure.
That's very
Okay.
interesting.
Yeah. JP12 actually followed up asking for a comparison between, like a competitive advantage comparison between Snowflake and the hyperscalers. I don't know if we already covered that or if we should give it another go.
Right. Yeah. So Snowflake versus hyperscalers. So basically, hyperscalers, three key hyperscalers, AWS, Azure, and GCP. Each one of them has their own competing solutions against Snowflake. What we are alluding here is mostly really about data warehouse. Obviously, Snowflake now is not only a data warehouse per se. Snowflake, they also have AI. They have AI platform as a service and data science. But if you're speaking about the data warehouse, for GCP, they have BigQuery, also for the data warehouse. And then for AWS, they have the Redshift, also for the data warehouse. And then for Microsoft, they have something called Synapse, also for the data warehouse. But I really don't think hyperscalers are a big competition for the data warehouse at this moment. It's simply because Snowflake has the cloud native architecture, so they're able to provide higher performance with cheaper cost. And what's interesting is that, yes, even for hyperscalers, even though they own the infrastructure, so by definition, they can provide cheaper service. But because Snowflake, it has a cloud native architecture that is so efficient, so they can not only compete on the simplicity of use, the user experience, but also competing on the performance. So unless hyperscalers, they can really bring in better, performance cost consideration versus Snowflake, then I think Snowflake right now is fine.
Why on earth don't Amazon hire a really good guy and then sort of do it better?
Yeah. Well, it's actually happening already. I mean, Amazon, they are a super competitive player. So they actually totally re-architected Redshift twice. So they kind of first re-architected Redshift back in 2017 when they saw the initial rise of Snowflake. And then they saw that, okay, oh gosh, they call it reinventing Redshift. But after reinventing Redshift, they basically invented every optimization that they can to try to catch up with Snowflake in terms of the architecture. But still, its performance per cost is still behind Snowflake. So I think it's quite telling in the sense that this just shows you how deep that moat is. Actually, building a data warehouse, building a world-class, most efficient, most powerful data warehouse is not easy. Generally, it takes 10 years to do so. And then what's interesting about Snowflake is that they were founded by two Oracle database kernel engineers. So basically, according to Altimeter, there were only 3 kernel engineers responsible for Oracle database, and 2 of them came out and then co-founded Databricks. So think about that.
Snowflake.
Yeah, the total amount of talent available globally who can really build out this data warehouse engine, super efficient data warehouse engine, is like within 10 or even within 5. And then 2 out of those guys are in Snowflake. So I think that's really the true tech for them.
Awesome.
I think there are Elon Musks everywhere, right? It's like these geniuses that can really move something in a different place. Like Jesper alluded to, that what would Tesla be without Elon? I think he's such a sharp engineer that if you want to win in manufacturing difficult stuff, then you need to have him as the boss. That's the best bet. That's at least my take on it.
Yeah,
but I'm a little bit fan.
The best, and also the best talent, they just prefer going with their own. They want us to have the founder control. They want us to be, a standalone company. They don't want us to, be in a bigger corporate umbrella. But I mean, for AWS, they are still good. I mean, they really make sure that they are not aging. They are not becoming a dinosaur that kills the innovation. But still, Amazon is very big. AWS is a very big organization. And a lot of talented engineers, they prefer to go with their own.
Yeah, I think that's, it's just human nature that some people just have this, everlasting desire to create, and they're gonna break out, and they're not gonna, keep doing things the way they've always been done. And then obviously the companies they found are always gonna be very mission driven and super reliant on that specific person or that little group that starts off in the beginning. So I think that's the reason for why innovation will just keep happening, right? No matter what, regardless of how monopolistic or powerful big tech companies eventually may become. We have a few questions we were actually asked last time, Simon, that we ended up saving for you because they were Intel related. Do you want to jump into the first one from Chris?
Yep.
Which is, what are your thoughts on Intel and ASML and the current build-up of chip fabs throughout EU and the US?
Yeah. So I think for Intel, they're just spending massively. So the interesting thing is that they are trying to think about, so the biggest issue with Intel, one of their biggest issues is that they stayed in 14 nanometer for just way too long. They stayed in 14 nanometers like since 2014 to 2021. So, generally, they should only stay in one process node for like 2 years or 3, but they stayed for more than 6 to 7 years. And the key reason was actually because back in 2014, when they were kind of planning, okay, what's next from 14 nanometer to next 10 nanometer. And then back in 2014, their only available lithography machine was just DUV. So they need to figure out the complex technology, they call it quadric patterning and also double patterning, to make sure that they can make advanced nodes with DUV. But fast forward to 2018, ASML proved that EUV is not only workable, but also very commercially viable in the high volume production environment. But for Intel, they have already gone to the DUV route for 4 years. So they said that, okay, we don't want to buy any EUV machine. We can make 10 nanometer just using DUV. While for TSMC, they entered 2018, and then they wanted to enter 10 nanometer and 7 nanometer too. And they said that, okay, EUV is available, let's buy it. And then they bought the EUV, and they saw that, okay, using EUV, they can bring in 7 nanometer, 5 nanometer faster. While for Intel, they was trapped in using EUV only. So I think that was part of the primary driver why Intel is behind in terms of the process node. So now Intel, it has its CEO, its first CTO back to the company, and he wants to bring in the technology leadership again. And then he thought about it, okay, we were kind of slow to adopt EUV last round. Now we need to adopt the latest round of technology ahead of others. So they are betting on high NA EUV, which is kind of the next generation of EUV. And they wanted to say that, okay, we are going to use this advanced machine faster than everybody else. And we wanted to kind of copy the playbook of TSMC or reverse it. Last round, it was TSMC who win massively because the progressive use of EUV. And now we want to be the winner of because of the progressive use of high NA EUV. So I think that's the interesting thing. And then maybe going to ASML, two things. So I think one good thing for them is that because everybody is kind of rushing into EUV and rushing into high NA EUV, the good thing is that previously, if you think about DUV, it's about just like 10% or 20% of the capex for the entire fab, for the entire chip manufacturing facility. But now EUV is getting very complex. It's going to take like 30% of the capex. And then if it is high NA EUV, it is going to potentially take more than 50% of the capex of one fab. So ASML, it is going to have more kind of share take in terms of the capex. And then for ASML, it's riding two tailwinds. So the first one is that you have greater digitization, so you have greater need for more chips. So therefore, you have more needs for lithography machine. But so that's for the volume. Another is for the ASP, the average selling price. Because we are going into EUV and high NA EUV, the ASP for the lithography machine is going to skyrocket too. So I think that's a good thing for SML. But the only caveat is that Chinese vendors, because they are blocked away from SML, and then now they need to build their own lithography machine. And although many experts said that it is very impossible for Chinese vendors to bring in kind of ASML level EUV machine anytime soon, but a funny anecdote is that Huawei, they released their own chip, Kirin 9000S last year, and it was reportedly using ASML lithography machine too. But this year, they released a new chip called Kirin 9010. And what's more surprising is that many people unpacked what's within their chip die, and they noticed that in the Kirin 9000S, there is still an alignment mark from the ASML lithography machine, which means that it was still manufactured by ASML 100%. But for their latest March 2024 chip from Huawei, no one can find ASML alignment mark. So either they removed their alignment mark or they are manufacturing it with their entirely own-made lithography machine. So if they can make their domestically made lithography machine, then ASML is going to lose at least 25% of their revenue.
Is that the new Huawei chip without the alignment mark? Is that still a 7 nanometer one?
Yes. It's a 7 nanometer equivalent process node, and then what they are planning on is building 5 nanometer. But for 7 nanometer, you can do it without EUV. But if you want to make 5 nanometer without EUV, it is going to be super expensive because the yield is not so low. Huawei is reportedly kind of using a mix of EUV plus better architecture. So right now the architecture of transistors are called FinFET. But the next generation transistor architecture is called Gate-All-Around. So they wanted to say we are going to bring in Gate-All-Around in the DUV process node, such that we can bring in equivalent 5 nanometer node process node. While for Intel and Samsung, and also for TSMC, they are only going to get Gate-All-Around in the EUV machine-based process node.
So they're all trying to catch up. The Chinese are trying to catch up, and Intel is trying to catch up as well. And Pat Gelsinger, he made. What are they doing? Do they seem to pull it off? And will they be a competitor to AMD on the server chips? And they've got Gaudi, that's a competitor on accelerated compute. And sort of take us through their product line and how they seem to be executing on their attempt to catch up.
Yeah. So, wow, that is a very big question. So,
yeah.
Three topics to unfold. So one thing is the process node leadership. Second is kind of the leadership in terms of the server CPU. And then the third is their potential in the AI chip space. So first, for their process node, I think they're executing quite well. Actually, with a little bit of delay, but so does TSMC. I mean, TSMC, they delayed their 3 nanometer node for like 18 months too. And then for Intel, relative to TSMC, it's definitely catching up very rapidly. And the reason is very simple, because previously it was just very reluctant to adopt EUV, because they found that, okay, we are the best. We have the best process node. So we don't need EUV. They have that kind of pride. And then now they are behind TSMC, so they recognize it. And then within Pat Gelsinger, he just said, okay, we are clearly behind. So we definitely need to use EUV. So they adopted EUV more aggressively. So that helped them brought 7 nanometer quickly. And now they are manufacturing 4 nanometer and 3 nanometer this year. So, TSMC this year, they are also in the 3 nanometer. So this is the year that Intel is going to have the process node parity with TSMC. And also, TSMC makes the chip for AMD. So this is the year that in the second half this year, Intel should have the process node parity against AMD. And in terms of the, and also for the next year, if they can really bring in 20A and 18A online, which seems like very likely as per what they have said, then they are going to have the process node leadership next year. And then in terms of the server CPU, the interesting thing is that it just takes 3 to 5 years to bring back the leadership. So it's not really as easy as like the software, like you see, okay, we are behind this one competitor, and then this competitor, because they have this architecture, they're ahead of us, and then let's do the same. There's a huge lead time in the world of chip design. It takes 3 to 5 years for you to really re-architect the chip and then ship the product. It takes at least 3 to 5 years. So this is, I think this is the year where Intel is going to really start to see the kind of parity, both in terms of the process node, but also the CPU design. So for the CPU design, 2 things. One is core count. How many CPU cores you can pack within one chip. Second is how performant one single core is. And then previously, Intel has been making very good single core performance, but it cannot pack a lot of cores within one chip because it didn't adopt chiplet, while AMD, they adopted chiplet very early on. And then this is the year, second half of this year, Intel, so for the previous few years, Intel was kind of always 50% behind AMD in the sense that AMD can always pack 50% more cores within one CPU. And then for some buyers, this is a great advantage. They wanted to save cost. So AMD is able to win market share from that standpoint. But into second half this year, they are going to release Grand 9 Rapid. And also AMD is going to release Zen 5 Epic, their server CPU. And this is the time when they have the same core count. The Grand 9 Rapids is going to have 128 cores. And also Zen 5 Epic, they're going to have 128 cores. So this is the time that they have the core count parity. Also the process node parity. So I think this is going to be a very interesting time to observe. So I do think that there's a very good chance that at least in the second half this year, they will stop losing market share. And then next year, they can really win more market share. And then that's just for the performance CPU. They also have a density-focused CPU based on efficiency cores. And vice versa, for AMD, they have something comparable called Zen 5C. But what's interesting is that Intel is making faster progress on efficiency core. So they are going to pack 288 cores within one CPU, while for AMD, they're going to pack 192 cores within one CPU. So think about that. In the previous few years, AMD is leading the core count, about 50% advantage. But potentially second half of this year and also next year, Intel is able to provide more CPU cores within a CPU within a chip. So potentially that is going to really change the competitive status. But we will see. And then the third element is the GPU or the AI accelerator. Also, I mean, a big question, a big discussion too. For GPU and the AI accelerator, you also need to separate the consumer and also for the server. So for the consumer, Intel, I think, is definitely ahead of AMD in terms of the computational power. The latest Lunar Lake versus AMD's Strix Point in terms of the AI compute power, Intel is definitely ahead. Intel has 48 TOPS NPU and also a total 120 TOPS of AI compute, while for AMD, it only has 50 TOPS of AI compute. So I think Intel should have a very great advantage versus AMD from the on-device AI. And then for the server AI, I think AMD and Intel, they are on a different strategy. So AMD is saying that, okay, NVIDIA is winning the game. So they don't want to compete head-to-head with NVIDIA. So they want to say, okay, we don't want to win within the training cluster. We don't want to compete in the AI training chip. They only want to compete in the inference chip. And then even within the inference chip, they don't want to say we want to provide the entire system to our customers such that we can compete head-to-head with NVIDIA. For AMD, they said that, okay, because they have the weaker hand, so they are going to partner with guys like Microsoft. Because Microsoft, they know how to build the AI system, while AMD only knows how to build AI chip. And NVIDIA is different. NVIDIA knows how to build the AI chip, but also how to build the AI system. So AMD said that, okay, we don't want to catch up with NVIDIA, competing NVIDIA on both AI chip design, but also AI chip system. They only want to build AI chip. And then Microsoft will handle the complex work of building the AI system and also the inferencing. And the good thing about it is that it is easier because the tough job is done by Microsoft. And Microsoft doesn't care about how complex AMD software stack is because it doesn't care. It just need to make sure that it can provide GPT-4 inferencing model as a service powered by MI300X such that they can reduce the price massively. But what that means is that most of the value add is taken by Microsoft or hyperscalers. And AMD, because that it doesn't do too much complex things like NVIDIA does. So its gross margin is going to be lower, its profitability is going to be lower. But what AMD is thinking is that, okay, even though it's lower, at least it's a good ROI. We can get a small chunk of the market share, and we can also get this market share with low investment. We don't need to invest hugely into system and software stack. We just need to focus on chip. And then for Intel, it's more ambitious. Intel wants to say that we don't want to compete just on the cheap, on the price, or kind of providing the chip, and then the value add is handled by the hyperscalers. Intel wants to say that we want to also build an AI training cluster solution competing with NVIDIA. And we also want to build an AI system that everybody can buy, every enterprise can buy. So they're definitely more ambitious. But based on what they are providing so far, their chip is still not very ahead of NVIDIA. So they have to compete on price. So we need to wait. So far, I think it's just fine. It's just the interesting thing is that Intel is the only commercial alternative to NVIDIA when it comes to AI training cluster. So if you want to build an AI training cluster, not using the NVIDIA chip, and also not using Broadcom, Broadcom, they design custom chip for Google for their TPU.
Yeah, I was
Intel
going to ask about
solution.
Broadcom, where they fit in and where they can start moving in.
Oh yeah. So for Broadcom, the thing is that they're not building the merchant AI chip. What it means is that you cannot buy Broadcom's AI chip out of the market. You cannot buy it from it directly. What it does is that it provides a custom design service for you, in the sense that it will co-design an AI chip with you. And their first success is the TPU with Google, whereby they co-designed the TPU with Google, and then they just plus a massive amount of money from TPU. This is a great business for them, but they are only going to serve for hyperscalers. So their second customer is Meta, because Meta, they spend more than $30 billion per year on NVIDIA. So they also want to say that, why should we pay NVIDIA if we have such a big scale, such a big budget? We can also go with Broadcom and let's figure out if we can design our own AI chip too, such that we don't need to pay so much money, so much premium to NVIDIA. And then the third customer presumably is ByteDance. And also it's a huge lead time. Again, it's going back to the chip design lead time. So Broadcom, they started the TPU partnership with Google about 10 years ago. And they only started the partnership with Meta just 2 or 3 years ago. And then Meta, they are not even having the chip yet. So the Meta revenue for Broadcom is going to show up only in the next 2 or 3 years. And then for ByteDance, they just announced it this year. So it's going to be reflected on their financial results, presumably 4 to 5 years later. So, this is a giant lead time to consider too.
What is it sounds like Microsoft is sort of using the AMD version. It's not completely an equal strategy where AMD is developing the chip and then Microsoft is incorporating, but Broadcom is co-developing and delivering IP, but Google is developing the chip and Meta is. What do you think? What does that competition look like? What is going to be the model of the future? Like ByteDance chose Broadcom. Are we going to see a lot of other big companies choosing a solution with AMD and Broadcom? And what do you think would be the prevailing solution?
So for Microsoft, it's more nuanced. So Microsoft, it has three strategies. So first, they buy lots of chips from NVIDIA, and then they also buy the chip from AMD, and then they design their own data center and then build up their own software stack on top of AMD AI chip. But they also have their own AI chip called Maya, and Microsoft, their AI chip is a custom silicon co-designed with Marble. So there's another vendor they co-design with Marble. So Microsoft is going on all three fronts. And then for Google, they also buy GPUs from NVIDIA, and then they have their own TPU. And then for TPU, it's not simply buying the TPU from Broadcom per se. Mostly, Broadcom is responsible for the chip design, while for Google, it is responsible for the software. But their chip is software defined, meaning that the chip is controlled by the software stack. So Google provides that software stack instruction to Broadcom, saying that you need to comply, these low-level hardware design aligned with our high-level software design. So that is where they have that co-design partnership altogether. And then where this is going to go, I think for hyperscalers, it seems like right now the trend is that they will going to design their own chip, because it just doesn't matter, just doesn't make sense at all to pay so much money to NVIDIA, especially for the inferencing, because for inferencing, the issue with going with your own versus going with NVIDIA is that NVIDIA, it has that software stack called CUDA, and everything, the ecosystem on top of that. So if you wanted to if you want to run AI, and then you run AI not only on NVIDIA, you're going to run a huge amount of issue in terms of the software integration, especially if you are an enterprise. But if you are a hyperscaler, you don't care, because at the end of the day, you only provide model as a service. So you can cover those software integration complexity by yourself. While for the users of AWS or Azure model as a service. They don't need to care about which underlying hardware that they are using, because what they care about is that, can I have this API access to have the model inference? And is it cheap enough? So I think for the inference, there's a good case to be made that it should be made cheaper with custom silicon, but also the merchant silicon from AMD and Intel. But for the training, it's still very complex. Training, you really cannot make training as a service. For most of the time, for the training, you need to interact with the software stack directly, be it if you are an enterprise or if you are using from the hyperscaler service. So this is still the space where NVIDIA has the moat. And right now, only Intel is trying to kind of compete with NVIDIA in terms of the training cluster that is commercially available.
Okay, wonderful. Here at the end, first of all, I just want to say thanks to Lucas KA for starting this whole discussion with his questions on whether it's like a winner takes it all or if Intel is really lagging behind. I think Simon has answered that really great and in detail. Just to finish off the stream, I want to have Simon dive into a question very quickly, which is, are the new Microsoft CoPilot PCs, should they be considered a threat or an opportunity for Intel?
Oh yeah. I think it's a super interesting question. So before the release, so if you go back kind of 6 months ago, like at the beginning of this year, Qualcomm, their Snapdragon X Elite is just amazing, just way ahead of everybody else. And Microsoft, their plan is to use Snapdragon X Elite to build an AI native PC experience to kind of compete with everybody else like Apple. And then the greatest thing for Snapdragon X Elite is that it has the foresight to increase the AI compute with NPU to 45 TOPS, very ahead. Because think about that, this is a chip, although this is a chip available in 24, this was a chip designed in 22. This is a chip that was designed before the Gen AI hype. So Qualcomm has that foresight to make a very big NPU before the Gen AI is in hype. So they have the vision saying that AI compute is in a big demand. So that's why there's a lot of hype about AI PC, and Qualcomm is going to be a winner, and then Intel, AMD are going to be a loser. But now we are in the middle of 24, and then what's interesting is that Snapdragon X Elite is still very powerful, but Intel and AMD, they are also releasing their next generation products. So Intel, their next generation product going to go on the market at the third quarter of this year, Lunar Lake. Previously, if it is in 24, at the beginning of 24, their comparable solution was Meteor Lake, whose NPU was just like 36 TOPS in terms of AI compute. So it is very behind X Elite. But now Lunar Lake is 120 TOPS. So it's more than double. But from the overall system perspective, it's kind of 50 to 70% better than X Elite in terms of AI compute. So this is super dynamic, constantly evolving competition. So from what's available right now, X Elite is now available on the market in the middle of 24, so it's ahead. But then in third quarter, Lunar Lake is going to overtake X Elite. So, and I think that's something that the market is now recognizing. It seems that the market has too much hype around Snapdragon X Elite. I think it is good. I mean, we were very bullish about Qualcomm X Elite opportunity at the beginning of this year. But now it seems that in the middle of this year, a lot of people have recognized the power of X Elite, and yet they're not recognizing what's coming out from AMD and Intel. So potentially, I think this is also going to be good for Intel, because what's going to come out in third quarter, they're going to take AI compute leadership back again.
Okay,
Just a last question, Simon. Intel as an investment, what's your take? What's the potential and what are the risks? Just very shortly, because we're out of time. But
So the interesting thing is that right now its market cap is like $129 billion, and its tangible assets is worth $100 billion. So think about that. The market is basically saying that your chip design, your intellectual property just doesn't it's not valuable at all. And then the market is also having a kind of, I would say, peak pessimism. I think the general consensus is that Intel is going to lose. They are losing the market share and they are losing on the process node. But based on what I'm saying, they are going to regain the leadership. They are going to stabilize on the market share competition second half of this year, and then potentially regain the leadership, gain more market share next year. And I think this is something that the market is now recognizing. And I find it quite funny. And right now we are in the inflection point. So Intel is going to be releasing the competing solution, very competitive products, closing the gap, relative competitiveness versus AMD. Now they kind of have the parity, and previously it's kind of like 50% behind. And then next year they can potentially be 10% or 20% ahead. So it's a very interesting time. And then the risk is that they can't deliver. If they're going to have more delays in their product launch, then this is going to be a big shock. But given what's been pricing, I think the market is already pricing in that without delay or with delay, they are not going to take more market share, but they are going to lose the market share. I think that's what the market is pricing in right now. So I think looks like we're sure.
Great. Okay, we're officially out of time, so I just want to thank Simon for coming by, and everyone else for watching. We'll be back in 2 weeks' time, as usual. But thanks for stopping by, Simon, and giving your insights on Intel and ASML and everything else. And have a great week, both of you.
Yeah.
See you guys.
Thanks everybody for tuning in. Thanks, Simon. It was a pleasure.